Morning, all of you. In this session, I am going to explain about simple problems on boiler joints. Problems on riveted joints. Before going to the problems, first of all, you have to know the fundamentals about types of failures in riveted joints. Already we have discussed in previous class. Just I remember. A riveted joint may fail in the following four ways: tearing of the plate at an edge. Okay, this is the first failure, tearing of the plate at an edge. To avoid this failure, you have to provide a suitable margin. Okay, margin is the distance between the center of the rivet and the nearest edge of the plate. Okay, the distance between nearest edge of the plate and the center of the rivet is called margin. Okay, to avoid this failure, we have to provide a minimum margin M equal to 1.5 times the diameter of the rivet. Second failure is tearing of the plate across the row of rivets. Here you can observe tearing when you are applying the tensile loads on the plates. Plates may fail across the row of rivets due to tearing of the plates. Okay. Third type of failure is shearing of the rivets. Here you can observe when you are applying the tensile forces on the plates, the rivet may fail due to shear off. Okay, this is the shearing failure. Fourth failure is crushing of the plate or rivets. Okay, this is the failure, fourth type of failure. Now, last three types of failures are very important for estimate the efficiency of the joint. Okay, tearing strength, shearing strength, crushing strength. These three are the very important for estimate the strength of the riveted joint. Tearing of the plate, already we discussed earlier. To avoid this failure, you have to provide margin M equal to 1.5 times the diameter of the rivet. Here small d is the diameter of the rivet. Okay, tearing of the plate at an edge. Okay, here you can observe. So M is the distance between the center of the rivet and the nearest edge of the plate. Okay. To avoid this failure, you have to provide margin M equal to 1.5 into D. Second failure, tearing of the plate across the rivets. Here you can observe. This is the second type of failure, tearing of the plates across the row of rivets. Okay, across the row of rivets. Due to the tensile forces in the main plates, the main plate or cover plates may tear off across a row of rivets, as shown here. In such cases, we consider only one pitch length of the plate, since every rivet is responsible for that much length of the plate. Here, PT is the tearing strength or tearing load. Okay, PT equal to cross-sectional area of the plates between the pitch length and tensile stress acting on the plate material. Okay, here cross-section area per pitch length equal to P minus DT. Okay, here we have to consider from here to here this length. Okay, this is the cross-section area of the plate. So P minus D into thickness is the cross section area of the plate. Sigma T is the tensile stress induced in the plates. So this is the formula for tearing strength. For design the riveted joints, we are using this formula, that is tearing strength. Tearing strength PT equal to P minus D into P into sigma D. P is the pitch. Okay, the distance between two successive rivets is called pitch. Okay, P minus D. D is the diameter of the rivet. T is the thickness of the plates. Sigma T is the tensile stress induced in the plate material. Plate material. Sigma T is the tensile stress induced in the plate material. Okay, this is the tearing strength formula. Okay, it is very important. And third type of failure is failure of rivet due to shearing. Here you can observe, when you are applying the tensile loads, the rivet may fail due to shear off. Okay, this is the initial position. Okay, this is the final position. The plates which are connected by the rivets exert tensile stresses on the rivets, and if the rivets are unable to resist these stresses, they are sheared off, as shown here. Okay, this is the shearing failure. Okay, so here this is a lap joint. This is a single strap butt joint. This is a double strap butt joint. Okay, these are the types of joints: lap joint, single strap butt joint, double strap butt joint. Okay, in single strap butt joint, in lap joint, here in lap joint and single strap butt joint, you can observe single shear. Single shear. So you have to consider single shear for a lap joint, and for a single strap butt joint, you have to consider single shear. In double strap butt joint or double cover butt joint, you have to consider double shear. Okay, rivet may fail due to double shear. You can observe rivet may fail at two places. So you have to consider two for double shear. You have to consider one for single shear. Okay. So here the resisting area is cross section area of the rivet. Okay, the resisting area is equal to the cross sectional area of the rivet. So pi by 4 d square is the cross sectional area of the rivet. 1 into pi by 4 d square for single shear. 2 into pi by 4 d square for double shear. Okay. For double strap butt joints, you have to consider double shear. For lap joint, for single strap butt joint, you have to consider single shear. Okay. For design of boilers, you have to consider double shear as 1.875 into pi by 4 d square for boiler joint. Okay. So this is the formula for shearing strength, PS. Okay, this formula is very important for design of riveted joints. Okay, this is the shearing strength of the riveted joint. Okay, for single shear, this formula for the single shear, for lap joint, for a single strap butt joint. Okay, this formula is used for double cover butt joint. Okay, that is a double shear. For boilers, you have to use this formula. Okay. Now this is the last type of failure, that is failure of a rivet due to crushing. Okay. Sometimes the rivets do not actually shear off under the tensile stress, but are crushed, as shown here. Due to crushing, the rivet hole becomes of an oval shape, and hence the joint becomes loose. The failure of rivets in such a manner is also known as the bearing failure. So this is the formula for a crushing strength. Okay, for determining the crushing strength, you have to consider number of rivets per pitch. D into T is the resisting area. D into T is the crushing area. Okay, sigma C is the compressive stresses induced in the rivet material. Okay, so you have to use this formula for crushing strength. Okay, now the efficiency of the joint. The formula for efficiency of the joint, zeta equal to least value of tearing strength, shearing strength, and crushing strength. Least value of tensile strength, shearing strength, and crushing strength divided by strength of unriveted plate, strength of unriveted joint. That is a P into T into sigma T is the strength of the unriveted joint. Okay. So by using this formula, you can determine the efficiency of the riveted joint. Okay. Now design of a longitudinal butt joint for boiler. Already we discussed in previous class. This is the butt joint, longitudinal and circumferential. This is a longitudinal butt joint for design of boilers. Okay. This is the example for longitudinal butt joint. The longitudinal joint is used to join the ends of the plate to get the required diameter of the boiler. Okay, for this purpose, a butt joint with two cover plates is used. Okay, this one and this one, these two are the cover plates. These are the rivets. Okay, according to the Indian boiler regulations, the following procedure should be adopted. So this formula is used for determining the suitable thickness of the plates, boiler plates or boiler shells. T equal to PD by 2T sigma L plus 1 mm. Here P is the maximum internal pressure in the boiler. Diameter, capital D is the internal diameter of the boiler. Capital D is the internal diameter of the boiler. Okay, small d is the diameter of rivet. Okay, don't confuse. Okay, capital D is the internal diameter of the boiler. Okay, sigma T is the tensile stress induced in the plate, boiler plate material. Zeta L is the longitudinal efficiency of the boiler joint. 1 mm is the allowance, corrosion allowance. Okay. Now, these are the efficiencies for boiler joints. Okay. These are the factor of safety for boilers. Okay, already we discussed in previous class. For determining the diameter of the rivet, you have to use D equal to 6 root T. This formula is applicable when the thickness of the plate is greater than 8 mm. Okay, we have to use this formula when the thickness of the plate is above 8 mm. Okay, but if the thickness of the plate is less than 8 mm, then you have to use PS equal to PC formula. You have to equating the shearing resistance of the rivets to the crushing resistance of the plate. PS equal to PC. From equation, PS equal to PC. Shearing strength equal to crushing strength. We have to use this formula for determining the suitable diameter of the rivet when thickness of the plate is less than 8 mm. Okay, when the thickness of the plate is less than 8 mm, then you have to use this relation. Okay, if thickness of the plate is greater than 8 mm, you have to use this formula directly. You can use this formula when thickness equal to thickness of the plate is greater than 8 mm. Okay, T less than if thickness of the plate less than 8 mm, you have to use this relation. Okay, shearing strength equal to crushing strength. Now these are the recommended diameters for rivet hole. Rivet hole diameter as per 1928 to 1961 Indian standards. Okay. By using this table, you have to select suitable diameter of the rivet and rivet hole. Now this is the formula for pitch of the rivets. This is the value of constant C. This table we use it for selecting the value of constant C. Now these are the formulas used for determining the row pitch. Row pitch or distance between the rows of rivets, or back pitch, PB. Now these are the formulas for determining the suitable thickness of the butt straps. T1, T1, T2 are the thickness of the cover plates. Here M is the margin. Okay. Now these six steps are used for design of longitudinal budget. Now I am going to explain about circumferential lap joint for boilers. Circumferential lap joint for boilers. For determining the thickness of the shell and the diameter of the rivets, you can use same procedure as discussed in longitudinal joints. Okay, and for determining the number of rivets required to join the plates, you have to use this formula for determining the number of rivets required. Okay, each of the rivets, number of rows. Already I discussed in previous class, so just please refer. Now I'm going to explain about problems on boiler joints. This is the example problem. A double riveted lap joint. A double riveted lap joint. Double riveted lap joint. Okay, this is the example for lap joint. Here, this is a double riveted zigzag riveting. A zigzag riveting is to be designed for 13 mm thick plates. Here, the thickness of each plate is 13 mm. 13 mm, this is the thickness of the plate equal 13 mm. Assume sigma T equal 80 megapascal, tau equal 60 megapascal, sigma C equal 120 megapascal. State how the joint will fail and find the efficiency of the joint. Okay, this is the form. This is the question for problem. Example problem 1. Okay, by using these details, we have to determine the efficiency of the joint. Okay, in this question, first you have to identify the given data. Here, the thickness of the plate T equal to 13 mm and sigma T. Sigma T is the tensile stress induced in the plate material. Tensile stress induced in the plate material. Sigma T equal to 80 megapascal. 1 megapascal equal to 1 Newton per mm square. Shear stress induced in the rivet material. Shear stress induced in the rivet material. Tau equal 60 megapascal. Sigma C equal to 120 megapascal. That is crushing stress induced in the rivet. Crushing stress induced in the rivet material or plate material. Now, from given data, first you have to identify the given thickness is greater than 8 mm. Okay, the given plate is greater than 8 mm. So that means is a thick plate. So first step, we have to determine suitable diameter of the rivet. Okay, the thickness of the plate is greater than 8 mm. Therefore, the diameter of the rivet hole is obtained from the relation d equal to 6 root t. Small d is the diameter of the rivet. Okay, diameter of the rivet. Small t is the thickness of the plate. Okay, d equal 6 root t equal to 6 root 13 equal 21.6 mm. Okay, this is the suitable diameter of the rivet. Okay, here you can observe, if thickness is greater than 8 mm, then you have to use this formula. When thickness is less than 8 mm, then you have to use PS equal to PC formula. You have to equate shearing strength and crushing strength for determining the diameter of the rivet. Okay, I will explain in next problem. Okay, now D equal to 21.6 mm is the obtained diameter of the rivet, but from standard sizes, you have to select a suitable size of the rivet. Okay, this is the size of rivet diameter for rivet hole diameter as per the Indian standards. Okay, so here the answer, diameter of the rivet D equal 21.6 mm is the obtained value from the standard table. You have to select the nearest value of 21.6 mm. The nearest value is 22. 22 mm is the diameter of the rivet. Okay, 22 mm is the diameter of the rivet, and 23 mm is the diameter of the rivet hole. Okay. Okay. Here from the table, you can select the suitable size of the rivet and the rivet hole. Okay, 22 mm is the standard size of the rivet diameter. 23 mm is the standard size of the rivet hole. Okay. Now the second step is wait. Okay. In second step, you have to determine the suitable pitch of rivets. That is the distance between two successive rivets is called pitch of rivet. Okay, the distance between two successive rivets is called pitch. So this is the formula for pitch. For determining the pitch of rivets, we have to use tearing strength and shearing strength of the rivets. Okay, by equating tearing and shearing strength of the rivets, you can get the value of pitch. So this is the formula for tearing strength, P minus D into T into sigma T. And this is the formula for shearing strength. Here N is the number of rivets. Here from given question, you can identify the type of riveted joint. That is in given question, the rivet type of riveted joint is a double riveted lap joint. For double riveted joints, you have to consider N equal to 2. For lap joints, you have to consider single shear. Okay. So by using tearing and shearing strength of the rivets, we have to find out the suitable length of the pitch. Okay. By equating equation 1 and equation 2, you can get the value of pitch. Pitch equal to 71 mm. Okay. But from the relation, maximum pitch is equal to capital C into T plus 41.28 mm. This is the relation for determining the maximum pitch of the rivet. Okay, here capital C is the constant value. So this is the table for selecting the value of C, constant value C. Okay. For double riveted joints, for double riveted lap joint, okay, you have to consider C equal to 2.62. Okay, this is the double riveted lap joint. Our given question is double riveted lap joint. So you have to consider double riveted lap joint. The C value is 2.62. So you have to substitute the value of C equal to 2.62 into thickness of the plate T equal to 13 mm plus 41.28. So this is the maximum pitch of the rivet. So here the maximum pitch is 75.8 and our answer is 71 mm. So this one is sufficient. Okay, 71 mm is the sufficient for pitch. Okay. Now the third step is row pitch. In third step, you have to find out the suitable distance for row pitch or back pitch. The distance between two successive rows of rivets is called row pitch or back pitch. Okay. So this is the formula for back pitch. For zigzag riveting joints, you have to consider this formula. The answer is 40 mm, 38.8 mm, or you have to consider rounded value as 40 mm. 40 mm is the row pitch. And this is the formula for margin. Margin M equal to 1.5 into D. Okay, this is the standard formula for margin. Okay, M equal to 1.5, D equal to 34.5 mm. Okay, this is the margin. Now, for determining the efficiency of the joint, first you have to identify the type of failure. Okay, so here this is the formula for tearing strength. This is the formula for tearing strength. Pt equal to P minus D into T into sigma T. Okay, the tearing strength is 49,920, and this is the formula for shearing strength. Here you have to consider single shear. Okay, N is the double riveted, so N equal to 2 pi by 4 D square into tau. Okay, the value is 49,864, and this one is the crushing strength. P is equal to N into D T into sigma C. 71,760. From these three values, we have to identify the least value of PT, PS, PC. Okay, from these three values, you can identify the least value is 49,864 is the least value. Okay, 49,864 newtons is the least value. So the joint may fail due to shearing. Okay. The given joint may fail due to shearing of the joint. Okay, shearing of the rivets. Now you have to identify the efficiency of the joint. This is the formula for efficiency. Least value of PT, PS, PC divided by strength of unriveted joint. Okay, yeah, the least value is PS. So PS divided by strength of unriveted joint equals 73,840. Okay, this is the formula for strength of unriveted joint. P into T into sigma T. Okay. So from this formula, the efficiency of the given joint is 67.5%. Okay, this is the final answer for this problem. Okay. The efficiency of the double riveted lap joint is 67.5%. Okay. Now this is the second example problem. The question is, two plates of 7 mm thick are connected by a triple riveted lap joint of zigzag pattern. Calculate the rivet diameter, rivet pitch, and distance between rows of rivets for the joint. Also state the mode of failure of the joint. The safe working stresses are as follows: sigma T equal 19 megapascal, tau equal 60 megapascal, sigma C equal 120 megapascal. Okay. First of all, you have to identify the given data. Okay. The thickness of the plate is 7 mm. Okay. So T equal to thickness of the plate T equal to 7 mm. This value T value is less than 8 mm. Okay, is less than, if thickness of the plate is less than 8 mm. Okay, for determining the diameter of the rivet, you have to use shearing and crushing strengths for determining the suitable diameter of the rivet. Okay, given data, thickness of the plate equals 7 mm and tensile stress sigma T equal 90 megapascal, shear stress 60 megapascal, crushing stress 120 megapascal. Okay, here the thickness of the plate is less than 8 mm. Therefore, the diameter of the rivet hole is obtained by equating the shearing resistance to the crushing resistance. Okay. If the thickness of the plate is greater than 8 mm, you have to use D equal 6 root T. Okay. D equal to 6 root T is the formula when thickness of the plate is greater than 8 mm. But in this question, the thickness of the plate is less than 8 mm. So you have to use PS and PC formulas. Okay. Here you can observe this is the diagram for triple riveted zigzag lap joint. Okay, triple riveted zigzag lap joint. So for lap joints, you have to consider single shear, and here N is the number of rivets. That means here the number of rows are 3. N equal to number of rows 1, 2, 3. So for triple riveted joint, N equal to 3. For triple riveted, number of rows equal to 3. Power for D square is the single shear and tau is the shear stress. So shearing strength equal to, here the diameter of the rivet. You have to find out the diameter of rivet. So the answer also in diameter 141.4 D square newtons. And the crushing strength N equal PC equal to N into D into T into sigma C is the formula for crushing strength. Here N equal to 3 and D is the diameter of the rivet, T is the thickness of the plate, sigma C is the crushing strength. Here the diameter D is unknown. Okay. So now from equation 1 and 2, you can get the value of diameter of the rivet. 17.8 mm is the diameter of the rivet. Okay, but from standard sizes, we have to select suitable size of the rivet. Okay, here our obtained value is 17.8 mm. So here the rivet size, the nearest value is 17.8 mm. So the nearest value is 18 mm. Okay. From this table, we see that according to the Indian standards, the standard diameter of the hole is 19 mm and rivet diameter is 18 mm. Okay, these two are the standard sizes. So you have to select these two sizes. Okay, this one is rivet diameter, this one is rivet hole diameter. Okay. Now, in second step, we have to find out pitch of rivets. This is the formula for determining the pitch of rivets. Okay. So for determining the pitch of rivets, you have to consider tearing and shearing strengths. Okay, tearing and shearing strengths. Okay, this is the formula for tearing strength. This is the formula for shearing strength. Okay, already we found the value of PS in step number 1. Okay. So here from these two equations, you can get the value of pitch P. Okay, P minus D into T into sigma T is equal to the 141.4 into D square. Okay. From this equation, pitch of rivet P equal 100 mm. Okay. But Indian boiler regulations maximum pitch is C into T plus 41.8 mm. From this table, you have to select a suitable constant C. Our given problem is triple riveted lap joint. Triple riveted lap joint. So C value is C equal to 3.47. Okay, 3.47 is the value of C. T equals 7 mm plus 41.28 equal to P maximum pitch equals 66 mm. So here 66 mm is the maximum pitch. So you have to consider 66 mm as maximum. Okay. Now distance between rows of rivets, that is back pitch or row pitch. The distance between two successive rows of rivets is called row pitch or back pitch. So the horizontal distance between two successive rows of rivets is called back pitch. So PB equal to 0.33 into P plus 0.67 into D is the formula for row pitch or back pitch. Okay. Here PD is the diagonal pitch. PD is the diagonal pitch. Okay. Now, in the last step, you have to identify the mode of failure. How do we know the formula for tearing strength, shearing strength, crushing strength? From these three values, you have to identify least value. Least value of PT, PS, PC. Here the PT value is 29,000, PS value is 51,000, and PC value is 47,000. Okay. Tearing strength is 29,000, shearing strength 51,000, crushing strength 47,000. So from these three values, you have to identify least value. Here the least value is for 29,610 for tearing strength. So the rivet may fail due to tearing of the plates across the row of rivets. Okay, the given joint may fail due to tearing of the plate across the row of rivets. Okay, so this is the final answer for our second problem. Okay, in next class we will discuss more problems on this concept. Okay, thank you.